Welcome to our data center transformation breakout session. My name is Alex Lam. I'm our Vice President of our Enterprise Business here for Fujitsu in North America. We have a very action-packed agenda. We're going to see if we can cram 45 minutes into 35 minutes. So I'm going to go ahead and just get started. So when we talk about transformation, I wanted to talk about transformation in a slightly adjacent industry just to kind of highlight how technology is changing the way businesses do things today. And so if you look at your current neighborhood bank, right, we all are familiar with this entity. This is a picture, judging by the hemlines, probably late 1960s, early 1970s. But why do people go to your neighborhood bank, right? Historically, we've gone there to withdraw money, deposit checks, obtain loans, store documents in a safety deposit box, maybe use some of the notary services there in the bank. And you know, for those of you that remember, they used to actually have free coffee there and even the occasional free toaster. But how is technology changing the banking experience for us today? So there's two areas. One is, if you look at technology that's focused on improving the internal operations of the bank, we have things, obviously, with the automation of things from the typewriter to the computer, things moving more to digital. We have phone systems that have been automated, you know, moving from a manual, picking up the phone to automated voice systems. Those of you that remember the air tubes, right, that you put the little deposit checks and they go through the little pneumatic tubes. You know, things like ATM obviously have relegated that. You can now drive up to your ATM instead of driving up to that air tube. And obviously, all the manual processes on the ledger have been digitalized and computerized. But what about in recent years, technologies that are focused on improving the actual customer experience? So if you look at things like your internet banking portal, the fact that you can probably do 95% of your banking needs digitally without having to step into the bank, right? That is a technology example that's changing how we interface, you know, with the bank, right? Things like mobile check deposit, the fact that you can just scan it on your mobile phone and you can deposit that check. Online loans, I don't know how many people get loans from a loan officer anymore. Most of it's done online. Things even as simple as PDF and DocuSign. The fact that you can do complex transactions, you know, buy a house, you know, sell a business, and digitally sign that and do it on a paperless transaction basis is changing how the speed of transactions for folks. Cashless payment systems, you know, the fact that you can start a business and take credit instantly through things like Square are improving things. Credit card reward systems, debit card systems, those are changing how people interface with things. You know, Starbucks, while it's not free coffee, you can order your coffee and pick it up, and there's probably a Starbucks in your bank already. And then for those of you that still are dead set on getting that free toaster, there's things like Groupon where you can find the next deal. So why am I bringing up this example? Well, you know, here's a slide I'm leveraging from my friend at Forrester, David Johnson. But his premise is today's CIO basically has a two-part to-do list. The first part is around what we would call traditional IT. It's the technology, systems, processes that are required to support the operations of the enterprise. So this is your classic keep the lights up and running. It's invest in technology that follows Moore's law. You know, as processors increase, you got to upgrade to the next servers. You know, as your storage capacity increases, you have to increase. As your customers grow, you need to have an IT that scales with that. But more importantly, we're seeing in recent years is the trend, the focus need for business technology, right? These are technologies and systems that are designed to win customers, to retain customers, to better service your customers, right? And so in that, similar to that banking example, these are the ones that will differentiate, the IT that will help differentiate for the company. And so if you look at the growth rates in these two areas, this is where we're seeing a dramatic shift in the spend. You know, this is looking at IT spend over the past 5-6 years. Traditional IT is growing probably around a 13% CAGR. What we see on the business IT side is 62% growth on that. It's obviously coming from a much smaller base, but this is hopefully a data point that shows the shift in mindset and mentality within the corporate IT market, right? I mean, you know, if you look at it, the CIO job is a tough job today, right? I mean, you get fired if things go down, but most likely you're going to get fired if you're not developing the IT infrastructure to better support your business. And so today's discussion is we're going to have experts. I have the easy job today. I'm going to turn it over to my team here. Mark Simmons is going to come up and talk about best practices in the data center and how those are aligned to helping CIOs make strategic decisions on how to structure better infrastructure design methodologies to help improve business technology. We'll have a gentleman from Veritas here to talk about how Veritas' partners and products are integrated with Fujitsu technology, for example, around SAP HANA with NetBackup, and how that will provide digital business value for our customers. And finally, I have Victoria from Grid Dynamics who will talk about the platform, the e-commerce platform that she's developed and her team has developed, and how that, once again, integrated with some technology from Fujitsu like our Spark M10 server, are providing value for our customers there. So without further ado, I'll turn it over to Mark.
Thank you, Alex. Good afternoon, everybody. My name is Mark Simmons. Many of you know me already. We've had some interesting discussions today. So we're going into essentially business transformation. The question that many people are asking, why business-centric? Alex has already touched on many of those things, but the CIO role, as he said, is pretty difficult. I wouldn't want to do the role that I did 15 years ago in running a data center anymore now. It's got quite horrendous. The CIOs tend to have to wear 17 or more hats, and it's not an easy hat to wear, and they're either too big or too small for the individuals, right? So what they have to deal with is these new demands, usages, technologies. Alex touched on some of those new disruptive businesses, Uber, Groupon, for example, some of the social media sites that have come into being recently. Problems that were not around 10 years ago. Many of you probably challenged, like myself, with some of the new technologies out there, and we get taught by our kids how to do this, right? So you're probably very familiar with some of these things. Right, data center transformation, the challenges that we find in this area, and being in the Fujitsu Enterprise Products Group, I have some pretty good insights into data center problems, as many of you are aware and also familiar with personally. These are typically grouped into these generic problems in the gray area here, addressing new data analytics. The new paradigm for buying, for example, consumer spending patterns. Dr. Joseph Rager this morning touched on that. The customer he was referring to was H&M, if those of you didn't actually recognize the picture. I've been involved in some of those things, so it's interesting. They've reinvented their stores, or are in the process of reinventing their stores with us. So they use these data analytics to see who's in the store, and he said what color people are looking at, things like that, to repurpose, re-optimize a store space, which is pretty expensive. Virtualized infrastructures, VMware's become virtual machine, and VMware become more or less a household name in IT. We see much more of that. So the server sprawl we all experienced in a past generation in IT has now extended itself to the virtual space. There's much more server crawl in the virtual space than there was in the physical. There are challenges there. Disaster recovery, that's a very interesting topic. We lump that in Fujitsu under a data protection umbrella. So we deal with that on numerous levels: backup, restore, RPO, RTO times, synchronization between data centers, things like that. The users are also getting more distributed. We're all used to using cell phones to access the internet wherever, whenever we want to. So delivering that to the end device is causing challenges. And the infrastructure to handle all of that is another big problem. The investment that has to be made to get that stuff running and keep it running has got more and more complex. So those are really the CIO challenges. So what this means, of course, is that they have to deal with a lot more people, resources, technologies than they ever had to before. They have to be much more well-read in their day-to-day operations. And this chart essentially summarizes the business environment being uncertain, trying to reduce environmental impact with power, cooling, things like that. I'll go through a couple of others, but the data explosion, of course, big data reared its ugly head like 2 years ago, started. It's now become more and more mainstream, so there's those things as well that they're very unfamiliar with and have to deal with. And then service expectations. This is one that's often forgotten. We expect a service to be delivered like that. Anytime we get on our phones or our computers, we expect that service to run, right? It's a normal expectation. However, delivering on that is really one of those challenges, okay? Oh, sorry. So this is just a summary, right? A collection of questions that we have garnered as Fujitsu from CIOs in a CIO forum. You know, for example, I'll just point out too, if my business started today, I would not need my own data center anymore. You've got Amazon Web Services, we have our clouds, HP has their cloud, Google has their cloud. Those services can be delivered from something other than your own, all right? I get less and less value for my ever-shrinking budget, and legacy IT is a problem. So we see many older systems continuing to be run when they could easily be replaced by something cheaper, faster, and probably more reliable. But there is a reluctance to move to new technologies that are not understood. We're all aware of that. We're human beings. We dislike change, right? So what we ended up finding is that we compiled this list of what CIOs need to ask themselves. And basically it comes down to, are your current solutions still good enough for what the demands are that are placed on them? Does your IT reflect the business? Is the IT essentially adaptable to the business change? That's the third one. Is it agile enough to adapt as your business models change? Those are really the four key things that any sort of strategy needs to formulate and address. You can see in here that there is a flexibility implication built in, right? And we think that the role of a data center will change radically. It'll become much more virtualized, it'll be decentralized, and it'll be remote from where the service is expected. The provisioning will become a much more precise art. At the moment, personal experience now, it tends to be very willy-nilly. Let's say one of your colleagues needs a new VM stood up. You'll just stand it up without looking at where, when, or how it gets stood up. It'll be templatized and you just get it. In future, that won't easily be possible because it'll be more demand-driven and it'll be more geared to the service, okay? So it'll be more precise. And IT outsourcing is going to change with the adoption of these cloud-like environments and landscapes. There'll be a lot more movement of data workloads around the planet. Low-risk transformation. So we have a methodology at Fujitsu called transition and transformation. It's basically a change and a reinvention of a service to take advantage of some of these newer constructs that we find being presented. And if you need a partner, I think this is really the plug for Fujitsu. We do all of those services to a greater or lesser extent all over the globe. And if you choose to change, there's a lot of value to be gained by adaptation or willingness to adapt. It's the lack of willingness that really prevents any progress, right? So to shape the digital future, this is sort of from Joseph Rager's presentation this morning. It's that shaping the digital future that really makes a lot of sense, all right? Thinking about big data, the Internet of Things, right? Process optimization, social media embracement, if you like, okay? And providing a business value, really that's the key. We think we do that pretty well. And focusing on some of that, you get some accelerated innovation coming in, so you can adapt quicker, you can innovate faster, and you can streamline the business processes, right? So I'll try and get on in the cognizant of time. So the infrastructure and business processes have some processes. We actually have best practices around these. We can implement these pretty rapidly with our business application services guys, with the enterprise people that we have, many of whom are in the room, and with the managed infrastructure services that we provide data centers to host all of this stuff. And the business-centric data center, I'm going to skip forward a little. We're basically there. We have coined a term, business-centric data center, to accommodate some of these agile technologies, some of which we have ourselves, some of which our partners like Veritas, VMware, NetApp provide to us, which provide these goals. And I believe these slides will be shared afterwards, so I won't bore you with details. And these business-centric data centers are able to change things. As you can see, there's an animated graphic here. Products, solutions, on-site, off-site, traditional cloud, self-managed or managed, these things are very variable with these data centers. And then maximizing the investment. You heard Dr. Rager talk about these things this morning as well, right? Triggers and drivers, looking at what those things have done, implementing and using the technology to do those change things. I think he had the example of the vehicle recognition in Japan. That's one of these things, runs in one of these data centers. And with that, I can hand over to Doward.
Thank you. All right. Good afternoon, everyone. My name is Doward Wilkinson. I'm a distinguished engineer with Veritas. And Veritas is very proud to be here and work with Fujitsu. My whole job is working with Fujitsu on a global scale. So I wanted to talk to you a little bit about some of the solutions that we've put together to work with Fujitsu, especially around the area of SAP HANA. So this is something that's really changing the data center. It's a transformational technology, an in-memory database that is allowing industries to really provide services to their customers in a very efficient manner. You know, we talk about going into a store, and if they buy something or they're looking at something, we can give the store managers or the salespeople up-to-date information. A lot of this is because they have an SAP environment behind there. We can provide, or SAP can provide healthcare services directly and in real time to doctors, physicians in a hospital environment, so patients can be cared for in the best possible way. So going out and analyzing and managing this type of environment is a transformation in the data center that is occurring. However, we kind of looked at this and we said, you know, there are some interesting places where we felt we can play with our partners, such as Fujitsu and NetApp, and bring our data center technologies such as NetBackup and be able to provide a solution that's sort of unique in the industry, and it solves a problem for those customers who are running SAP. So, you know, disaster replication provides disaster recovery, but it is not, doesn't address the problem of corruption in a database. So when you replicate data, which now today in the cloud and in various other places, people do replicate data, but you're, in many cases, if that's your only solution for recovery, you have replicated corruption in some cases if that occurs. So to have a complete data protection type of environment, you need backup. And Veritas NetBackup is probably the largest footprint out there. And you need DR. There's clearly a need for both. So what we went out and did is working with the SAP API, working with Fujitsu, and working with NetApp, we were able to go out there and create a solution that improved upon some of the situations that they have today. So today, typically in an SAP type of environment, they have a backup API, and many other backup solutions tie into this backup API. But it's streamed data, so you can back it up, but it's a large amount of data. It doesn't give you the ability to do what we would call granular recovery. So you've identified a problem within the database, there's some corruption, something has happened, and you have to recover a lot of data to get back into that point in time. So working with NetApp and Fujitsu, we created a snapshot technology based on SAP's API and NetApp's API, and we were able to go out there and create very granular point-in-time snapshots of SAP data with NetBackup. So we can take these snapshots every hour, every half hour, with minimal impact on the server, and the backup servers don't have to be quite as large anymore because you're taking all these snapshots. You're not streaming massive amounts of data where you have to have a huge I/O engine out there to work with them. And then in the event of an event that occurs, we can go out there and we can take those snapshots and restore them back into the SAP at a certain point in time that's, as I said, very, very granular in nature. So we think that this is sort of innovative technology. We have our mainline products. We're in the data center. We work with Fujitsu in a lot of areas in the data center. But something like this is where we're taking Fujitsu, a Fujitsu partner such as NetApp, and a partner such as Veritas, and creating a unique solution around all of these, around an offering that Fujitsu has a very, very strong footprint in. So we enable these storage snapshots with SAP. It's based on SAP HANA's API, so it's certified by SAP, the snapshotting technology. We have that tied in with our NetApp application director, and we're able to provide this solution for point-in-time recovery quickly of SAP HANA solutions. So anyway, that's what I wanted to talk about and touch on, and we can take any kind of questions after the event here today.
Hello, my name is Victoria Lifshitz. I'm a founder and chief technology officer of Grid Dynamics, Fujitsu partner. And in many fascinating conversations that's been happening from, I don't know, last night, dinner and drinks, and all the way through today, the words that I hear all the time is big data, probably number one, analytics, particularly real-time analytics, and cloud. And what I thought I will do today is take maybe 10 minutes or so and talk to you about what it actually takes to run real-time analytics infrastructure. And I'll tell you a little bit about what is business analytics, what is real-time business analytics, what are bits and pieces of technology that make real-time insights in various business domains possible. So it's not a product talk at all. I'll just talk about try to demystify a little bit what that real-time analytics is really all about. So what I want to do today is introduce to you a new and upcoming technology that's getting a lot of buzz, a lot of interest, that's called in-stream processing. And I'll discuss some use cases, business use cases for real-time analytics, and illustrate some of the up-and-coming, some proven and some new frontiers for the in-stream processing. And I'll present to you very, very briefly at the high level kind of a complete end-to-end technology blueprint that consists 100% of open source components only and can run on any cloud, private, public, and anything in between. Just a little bit about myself. I'm a career technologist and senior serial entrepreneur. Grid Dynamics is one of a few ventures that I've started over the course of my career about 10 years ago. We are a leading provider of engineering services to tier 1 companies in fin services, retail, telco, high tech. And we focus on this transformation to the cloud for mission critical, massively scalable architectures. In prior life, before starting the company, I had a privilege of working about 10 years for Sun Microsystems. The last thing I did for Sun, I was the architect for SunGrid, which was the first public cloud in the industry, predating Amazon by a couple of years. So a career here was dealing with these kind of issues and personal delight in seeing cloud computing and big data finally adopted at a massive scale. So what is a typical big data landscape in the enterprise? And this is a very, very simplistic way to think about it. But basically, you can think about it as you want to build a data hub. And the key modern cool word for it is data lake. So you want to create that lake that basically all kinds of data floats into. And it aggregates massive amounts of structured and unstructured, mostly unstructured data. And then you want to be able to apply various things, various processes to do some stuff with that data. And that broadly falls into category of what sometimes is called batch processing or offline analytics, or real-time processing or online analytics. And then underneath there is this bubble that Neil talked about earlier in the previous session. That's all about data science. That's about minding those informational mountains and lakes and trying to make some sense out of it and apply models, smart models that tell you something about data patterns that can be exploited for business purposes. And then the typical recipients of all that kind of fall into two categories. One is the customers. And typically this happens through online systems. You have some kind of application, people are shopping, people are paying, people are researching, or they're on the social channels. And you're starting to insert yourself in a better personal experience through aggregation of these business insights. And a lot of other applications are more on the back end for things related to first response systems, fraud detection, customer service, outage prevention. So at a high level, this is kind of what the big data world looks like. But if you start peeling under the cover a little bit, and this is still a very conceptual diagram, you see a ton of complexity. Now, we try to remove the complexity and look at it in terms of broad categories of the type of processing happens. And what you see is on the left-hand side, you could think of various source systems that create events. This is your Internet of Things. These are your credit card transactions as they have been swapped. These are payments. This is somebody clicking on a product recommendation and producing event. These are all of your sensors that are out there collecting information constantly. There's billions and trillions of informational events, little ones, but happening all the time. And the job is to collect all that and then send it to some kind of systems. And today, usually, there's some kind of a line of business systems that aggregate it. Maybe CRM system, payment system, loyalty systems, right? In every enterprise has some number of those. And then more and more, there is external services. Maybe those are provided by your partners. Maybe if you're in the retail, it's Core Metrics, right? The IBM service that is collecting all these click streams. And now what you want to do is that data is locked in a proprietary formats across different specialized applications. What you want to do is you want to get them out of there and put them in your data hub. So there's multiple different adapters that you put to suck the data out and put it in that hub. Now, once in a hub, you could do various really, really interesting things with it. But in the end, what you want is you want to find the insights and send it out to another set of applications, line of business applications or BI analysts or data scientists, so they can act on it. And so your data hub tends to be something that aggregates the data, and then you put a lot of processes in place to get the data in and then get the data out. At a high level, this is sort of a meta pattern, meta approach. Now, there is one particular part of all of this that I will spend the rest of the 5 minutes on, and that is real-time analytics, or as I will describe, in-stream processing. Now, what does it do? And what is real-time anyways? Now, there's different definitions of real-time. In this kind of system, we are looking at, first of all, data volumes. Something from 1,000 to upwards of 100,000 events per second. That's how powerful systems like that are. And there are some applications that are even bigger than that. for example, Dow Jones processes north of or maintains real-time portfolio values for over 1 million different portfolio combinations that they have to recalculate on every market tick. That's roughly 1 million portfolio calculations per second. Think about the volume. Latency. When we talk about real time, and this is business real time, we typically want to know that something happened roughly within a less than a minute time frame. Now, some real-time systems deal with microseconds. Those are things like real-time trading systems, those things like safety systems, right? Well, different architecture is required for that. But we are not talking about 1 minute to detect that something happened or less, basically from 1 second to maybe 30 seconds. And then some time to issue the business event. Generally, when the business response is under an hour, the only way you could do it is with these kinds of architectures. Now, here's some examples of use cases. Stream click analytics, extremely powerful in retail. You want to be custom. You want to be. You have recommendation engines that issue specialized coupons, offers, promotions, ads, tailor search results based on who is looking, who is clicking. Preventive maintenance is getting more and more traction, and this has actually been able to predictively spot problems in the data center or with equipment of networking or whatnot, and then feed monitoring systems that take preventive steps to stop the issue from happening. Fraud detection, a lot is written and said about that. Really cool one is emotional analytics, and people are doing more and more about that. There is call center applications, for example, that can analyze the tone of voice of the customer as he is speaking, detect the escalation patterns, and automatically route the call to the supervisor to de-escalate before it progresses any further. And dynamic pricing engine is actually something that will determine a price on a product at a specific moment in time based on who is looking, what is a competitive pricing, what's my inventory availability, and things of that sort. And this is just barely stretching the surface. So how does in-stream processing work? Very broadly, it takes input from all kinds of systems, then does its magic, and then when it finds something interesting called actionable insights, it's going to notify the right systems down the stream. Now, if I look even deeper in their cover, what does it look like? It tends to consist of roughly these big chunks, right? This is a system architecture. There is events that are coming in, and typically they're entering big, powerful queues. And these queues collect events, and they persist the events, and then they queue them up for processing. Actually, these queues have to be done in an extremely sophisticated way in order for these kinds of systems to operate at the scale that we're talking about. And then it issues this strong stream processing framework, and that framework has some data stores, and it has some reference data, but it's basically optimized to do a lot of things in memory, and optimized to do it very fast. And then when insights are found, it has to produce results and deliver it somewhere. Now, you double-click now inside the stream processor, and what you see is a very sophisticated and fairly specialized machinery just for analytics processes itself. And it's got library of functions, if you will, and specific data structures to operate on things like sliding windows of events, because often you actually want to correlate and find minimums and averages and other things in a collection of events that are happening roughly at the same time. You have specialized filters, you have aggregators, you have enrichment functions, and so forth. So these are all bits and pieces of machinery, if you will, that you'll find in the typical DSLs related to stream processing. Now, if you now start, peeling the onion even farther, and I won't cover these slides, but it basically gives you some even more deep machinery of why it scales so well, and why is it so resilient, and why is it so persistent. And there's a lot of stuff that built into these in-stream processors that allow these systems to operate that way. And a huge amount of effort on these architectures is put on parallelization, designed for parallelization at scale. Every bit of computing is containerized. And then the servers are designed in a way that can run lots of different containers concurrently. And so all that advancement that actually happened in the distributed computing space probably over the last 20 years or so, now coming together in these reference architectures and these products to enable these kinds of things, it's incredibly compelling price points. And then when you're done, you want to deliver these insights to somewhere. But again, there's a variety of different ways in which you might want to deliver those data points, often depending on how mission critical they are. If they are what we call critical insights, like fraud alerts, then you want to deliver it through some kind of API right away. But in many other times, you want to have what we call insights on demand. We basically discovered something interesting about this user. We're going to keep up with that information. Next time that user registers somewhere, go and look it up and ask what was interesting about this particular user profile, and we can tell you, right? So, and kind of everything in between. Now, what's really, really interesting is cool, and this is where, so far, it's kind of a general knowledge. A little bit where grid dynamics comes into play, and now with 10 years of experience building very large-scale production implementations with this stuff, is what I call a blueprint. How do you put these complex technologies together and create one reference architecture? And we have done this, and this reference architecture done 100% with open source tools. Free software is very good. Now, these are leading products in its own space. This is a leading stack, if you will, with which companies are building in-stream processing systems. We have put together a lot of deployable, scalable, manageable configurations with the backups that are built and restore, and multi-data center architectures built into it. And they are infrastructure agnostic, meaning that you can pick up that stack and you can throw it in Amazon, you can throw it on Google, you can throw it on OpenStack, or anywhere else where your cloud story takes you. So in summary, real-time analytics is big and growing part of data center landscape within enterprise. And I would actually say that it's real-time analytics that is starting to bring business value to the quest for big data. A lot of companies have been hoarding data on the concept that it must be valuable, and they are right, it is. But now they are asking the question, well, just how valuable, and what do we do with it? And there's amazing stories of companies that have discovered billion-dollar new markets that are based on their ability to collect the data, but then understand the data and then make it actionable. How does that work? Events are coming in from a variety of source devices, enter the age of Internet of Things. They mined it for something interesting, and then results are delivered specifically to the targeted system that know what to do about it. The goal is to process events in business real time. And stream processing is really kind of a new kid on the block that holds a lot of promise to providing very, very compelling capabilities as very compelling price points. Everything is designed for speed, resilience, throughput, and scale. And there is, without diving too much into details and weeds, a very stable and proven set of open source technologies that give you that. And if you ever wanted to know more, drop me a line. Read my blog, our blog, and talk to us. We've been helping large companies build systems like that for 10 years now. Thank you.
Thanks, Victoria. So this concludes our presentation, but what I'd like to do is maybe take a couple minutes if there are any questions from the audience. We have the panel up here. And I think we have a mic out there. Anyone have? Grid dynamics, is this a competing product with Splunk and Hadoop, or is it overlay? Is there any play there?
The question if it is competing with Splunk or Hadoop. No, so Hadoop is very much a part of it. So Hadoop tends to be the technology behind the data lake. And stream processing are other Hadoop ecosystem type of technologies that focus specifically on the real-time piece of it. Hadoop itself is not a real-time technology, but broadly, Hadoop ecosystem has bits and pieces that I've showed that all are working together. Splunk is basically a commercial company that has a specific set of very cool applications and infrastructure related to big data. They use similar type of approaches to solve it commercially, if you will. This is general purpose. You can use it for log monitoring and management, but you can use it for so many more things that This particular talk and technology stack is about real-time analytics, and the key is a collection of open source technologies designed to run on the cloud.
Does Fujitsu have a business intelligence product? I don't remember seeing such a thing upstairs, and you mentioned, and other people throughout the day have mentioned business intelligence, and I just wonder, is there such an offering from Fujitsu, or am I making this up?
No, absolutely. There's a suite of products hidden cunningly under the umbrella name Interstage, INTERSTAGE. We have a couple of people here I can introduce you to afterwards. They own that. There are things like a product called APD, which is Automatic Process Discovery. So you run it in a landscape to see how processes actually work. We have products around BPM, Business Process Management. There is a BI product. That said, although Fujitsu has its own, we also do the, let's say, SAP BI and the Oracle BI as part of our overall delivery strategy. But yes, we have those products.
Okay. Well, if there are no more other questions, I'll conclude it now, but obviously the panel here is available to take any questions here or later in the reception. So thank you once again for coming to our talk. Thank you.